again, and so we continue with another leading forward talk about like imbibing sustainability into software development. So now it was software for energy, let's say providing and at some points long-term sustainability of energy. But now we will see the software aspect with Aman. So if Aman, hello Aman, how are you?
Hey, I'm good, thank you. How are you?
We're doing really well, and we're really glad to have you to talk about like how to make software more sustainable for the long term.
Yep, I'm really happy to speak to everyone today. Thank you. Awesome. Okay. So yeah. All right. Hey everyone. So my name is Aman Dhamija, and I'm really thrilled to speak to you all today about green software engineering and how we can imbibe sustainability in software development. So, a bit about myself. I'm a software engineer at Goldman Sachs, and I was introduced to green software engineering through our firm's membership with the Green Software Foundation. And this is a field that I'm particularly passionate about because I think it's really great that there's something that we as software engineers can do to help with the climate crisis. It has been quite a journey of learning, and I'm really excited to share that with you all today. So, let's get started. So, what is the Green Software Foundation? Well, it's a nonprofit that's formed under the Linux Foundation with the mission of building a trusted ecosystem of people, standards, tooling, and best practices. The foundation's vision is to change the culture of how we build software such that sustainability becomes a core priority and is just as important as something such as performance, cost, or accessibility. And with net emissions increasing in the IT industry each year, it's very important for us to put software at the center of our sustainability discussions. But what is green software in the first place? Well, there are two ways of looking at software: software as part of the climate solution, and software as part of the climate problem. Now, we want to see software as part of the climate solution, and therefore we want to focus on reducing the carbon emissions from software. So currently, there are only three ways of doing this: using lesser physical resources, using lesser energy, and using energy more intelligently. So essentially, green software is carbon efficient software, which means that it emits the least amount of carbon possible. So, how do we go about building green software then? Well, it's important to understand the principles of green software and then put them into practice. So, the principles are energy efficiency, hardware efficiency, and carbon awareness. Now, before we do a deep dive into these principles, it's important to understand the concept of carbon efficiency, which is at the core of all of these principles. Did you know that just 1 hour of streaming produces the same amount of carbon emissions as charging 7 smartphones? And so, for every gram of carbon that you emit into the atmosphere, you want to extract the maximum value possible. And therefore, a carbon efficient application emits the least amount of carbon possible. So, our goal should always be to be carbon efficient. With that in mind, let's take a look at our first principle, which is energy efficiency. Now, energy is the ability to do work, and it can exist in many forms. And we can convert one form to the other. So, in that way, we can actually think of energy as a measure of the electricity that's being used. But is our electricity even clean? Well, most people think so because whenever they plug something into the socket, their hands don't get dirty. However, most electricity is actually produced by burning fossil fuels, and therefore, energy supply is one of the single biggest contributors to carbon emissions. And so, if we want to be carbon efficient, then we must be energy efficient. So, one way of improving energy efficiency is to understand the concept of energy proportionality. Now, I myself have been guilty of this. But I am sure that there are many people in the audience here who never actually switch off their laptop or their PC when they're not using it. And let me try to explain why we should avoid doing this. So essentially, the more that we utilize a device, the more efficient it becomes at converting electricity into practical computing operations. So if you take a look at this graph, let's assume you have a device which at 0% utilization um, consumes 100 watt of power. When it reaches 50%, it consumes 180 watt. And when it reaches 100%, it consumes only 200 watt. And so from this, we can see that the relationship between the electricity that's consumed by a device and the rate at which it does useful work is not linear. And so if we want to be energy efficient, then we must ensure that we extract the maximum utilization possible out of devices that are consuming electricity. Coming to our second principle, we have carbon awareness. Now, I know that we spoke about the fact that our electricity isn't clean, but how do we know how dirty our electricity is? Well, depending on your location or point of time during the day, electricity is actually produced from a variety of different sources, having varying carbon emissions. So, some sources, such as wind or solar, are renewable, whereas others, such as fossil fuels, can be quite polluting. So, let me introduce to you a term called carbon intensity, which basically measures the amount of carbon emissions in gram per kilowatt hour of electricity that's being consumed. And so, if our goal is to build carbon efficient applications, then we must ensure that we utilize our electricity more when the carbon intensity is lesser. So, carbon intensity varies by location. And this is primarily due to the fact that certain regions have an energy mix in which the proportion of clean energy is greater. It also varies by time, and this is due to the variable nature of renewables itself. So, if you take a look at this graph here, you'll see that even though the demand for electricity remains the same, the carbon intensity of the bar on the right is much greater than that on the left. And this is because at that point in time, the wind may have stopped blowing or the sun may have stopped shining, causing your power grid supplier to rely more on burning fossil fuels to meet the same demand. So, this brings us to a concept called carbon aware computing. And this basically says do more with respect to your compute when the carbon intensity is lesser. This can be achieved by a concept called demand shifting, which is possible when you have flexibility into where and when you can run your workloads. So, one way of achieving this is by spatial shifting, in which we basically move our compute to a different location where the carbon intensity is lesser. Another way is by temporal shifting, in which we basically run our compute or our workload during a different time in the day, such that the carbon intensity is the least. And doing this not only reduces our carbon emissions, but it also helps accelerate the energy transition to lower carbon sources in the future. Coming to our third principle, we have hardware efficiency, in which we examine the hardware that's used to build our software. So, every device that we've come across has caused carbon pollution during its creation and destruction. And this is called the embodied carbon of a device. And it's actually a hidden cost when we want to consider the carbon emissions from software itself. So, to put things into perspective, if you take a look at this graph, you'll see that for most end user devices, the embodied carbon emissions are actually much greater than the lifetime emissions from their consumption of electricity. So, how do we go about improving hardware efficiency then? Well, it's actually quite simple. For end user devices, it simply means extending the lifespan of your device, whereas for cloud computing, it means increasing utilization. And to show you how much of a difference this can actually make, let's take a look at a few examples. So let's say you have a device which has 1,000 kgs of embodied carbon, and the expected lifespan is 2 years. That means you end up emitting 500 kgs of carbon every year. But if you were to just extend the lifespan of that device by 1 more year, then that would mean your carbon emissions would drop down to 333 kgs per year. And I really hope that this convinces you not to upgrade to the newest model of your smartphone or PC just yet. With respect to utilization, we can see here that it's actually much better to just run one server at 100% capacity rather than running 5 servers each at 20% capacity. And thereby, each server would actually contribute to the embodied carbon cost on an individual basis, which would add to the total, and we don't want that. So let's do a quick recap of what we've just learned. So the three principles of green software are energy efficiency, which basically says consume the least amount of electricity possible, hardware efficiency, which says use the least amount of embodied carbon possible, and carbon awareness, which says do more with your electricity when it's clean and less when it's dirty. Now, before we take a look at how we can actually put these principles into practice, let's try to understand how we can measure the carbon emissions from our software itself. So, the Green Software Foundation came up with the software carbon intensity specification, which is basically designed to score your application along the dimensions of sustainability and encourage action towards elimination of carbon emissions. So basically, it asks to bucket the emissions from your software application into two categories. The first one is operational emissions, which arise from running your application. And the second one is embodied emissions, which basically are emissions that are happening from the hardware that's used to run your software. So if you take a look at this equation on the screen, the first term, E into I, represents your operational emissions, where E is the energy consumed by the software, and I is the location-based carbon intensity. The second term, M, refers to the emissions from the hardware that's used to run your software. So essentially, this equation becomes carbon per R, where R is a functional unit that defines how your software scales. So, for example, do you want to calculate the carbon per number of end users, or do you want to calculate the carbon per number of API calls, or per number of ML jobs? It entirely depends on how you define what the scaling unit is. So now that we've learned what the three principles of software, of green software are, and how we can actually measure the emissions from our software, let's take a look at how we can apply some of these principles into practice. So from a carbon emissions perspective, it's actually much better to cache static data such as images or audio instead of transferring them over the network, because the lesser the distance data has to travel across the network, the lesser electricity that's required to actually move it across, and therefore the lesser carbon emissions happen. Similarly, the embodied carbon cost also goes down because your data has to travel across reduced number of servers. When you want to deploy your application on the cloud, you should choose a region that's basically closest to where majority of your users are. And this is because the network traffic is reduced and thereby your carbon emissions also reduce. So now let's take a look at a case study whereby UBS and Microsoft came together to put into practice the concept of carbon-aware computing. So UBS has a core risk platform on which they run Azure batch workloads. And they basically wanted to see if they could use the concept of time shifting to reduce the carbon emissions from their jobs. So the Green Software Foundation has an open source project called the Carbon Aware SDK, which is essentially a web API and a command line tool that's capable of measuring and predicting the carbon intensity of a particular compute, given that you provided a location and a time period for which the compute will run. So they use the Carbon Aware SDK to calculate the carbon intensity of a workload that had already run in the past, which was essentially a job that ran for 15 minutes. This came out to be 719 grams of carbon per kilowatt hour. They then queried the carbon aware SDK throughout the day at an interval of 5 minutes so as to find an optimal time window during the day such that they could run their job and the carbon intensity would be the least. And so the carbon aware SDK predicted such a window, and basically the prediction for the carbon intensity of that window was 659 grams of carbon per kilowatt hour. Then they actually executed their workload during that estimated time window, and they found that the carbon intensity had actually reduced by 10%. And for their MVP solution, they focused on reducing the carbon intensity in their efforts to reduce carbon emissions from their overall job. So this brings us to the end of my presentation. And if you're interested in learning more about green software, then the Green Software Foundation and the Linux Foundation have launched a free course that can help you to build, run, and maintain greener applications. You can find more information about this on the Green Software Foundation's website. Thank you so much for listening to me, and I'd be happy to answer any questions you have.
Thank you very much. Thank you very much, Aman. Thank you for all of this. So at our London conference, we had Sarah Sue, who is a colleague at some point,
Yeah.
who were explaining us like the interest of the Green Software Foundation and what you do. So today, to your mind, what is let's say, what is the main sponsor of such initiative? Is it more the business? Is it more the tech side, the compliance side, or the ESG side of the company? How does that work to implement?
Sure. I think this varies from like company to company. Particularly like for us, I think we're interested in kind of spreading awareness about this at the grassroots level, and we as engineers are really passionate about this. And we look at how we can use our learnings from the foundation and apply it into practice. But yeah, I think for other companies as well, they are conscious of their ESG efforts, and this is a very interesting space which can have a lot of impact, given that the software emissions are contributing so much to carbon emissions overall. So I think that might be an interest for many people to join this platform.
Yeah, totally understand. Also about the impact, sometimes there's always the debate, software versus hardware. So is it does the Green Software Foundation focus on just the software part, which is already something, or where the hardware is included, or if it is?
Sure. Yes. So the embodied, like the carbon emissions from hardware, which is embodied carbon, is a cost that is often maybe not seen at the first time when you think of carbon emissions from your software. But the foundation and especially this field that we're exploring encourages us to consider the carbon costs that comes from your hardware, which are actually very significant, and sometimes for end user devices even more significant than their lifetime consumption of electricity. So we have data sets that we're compiling that can basically tell us, for this particular hardware, this is the amount of carbon cost that you should consider when calculating the carbon emissions from your overall software applications. So yes, we would want to take into account the hardware as well as the software when thinking about emissions.
There's also a question about the storage or the network, or how do you decompose the runtime of the software versus the, let's say, what's around the software use, like the bandwidth or the storage?
Sorry, can you repeat that?
No, how do you count or calculate to consider what's around the software runtime? Like the ability, the fact that you're running the software, like network bandwidth or storage, long time storage, or how does that count into the green software practice?
Sure. So whenever we want to actually calculate the carbon emissions using the SCI, we want to establish a software boundary basically. And so this boundary should ideally include everything end to end that's used to run your application. So yes, you'd want to take into account the emissions that are, from your storage devices as well as the network traffic as well. And we kind of want to use that into our calculations, and our effort should be to reduce everything within the software boundary when it comes to carbon emissions.
Yeah, perfect. Thank you very much, Aman. Thank you for answering the question. Thank you for being there and presenting us SCI and the Green Software Foundation. And looking forward having you at another apidays conference.
Thank you so much for having me. It was an honor. Thank you so much.